don't have a long record of data, you just make a speculation. That is the problem in a developing country. Yeah. But in a developed country, they have a long observation. Right. So, now we have a limited place in terrestrial, on the surface of the Earth. Yeah. You travel from time to time, and if you see the space here, you see there is no islands here. How to measure this here? There are large gaps in the southern hemisphere. Yeah. So people think how to overcome this problem. So they launch satellite. Satellite altimeter. It's quite simple. It's like tide gauge, radar gauge on space. From here, see this one. So thanks for GNSS, the orbit accuracy is high. It's about 2 centimeters, the accuracy of the satellite altimeter. In 1994, when I did my PhD, I was asked to do orbit computation. At the time, quite small. I mean, quite a small number of satellites, 94. I did this computation. At the time, it's hard to get 2 centimeters accuracy of the orbit using scientific software. But then now it's quite easy. So when you get this, the position of the orbit of this, so you can determine this, the distance, see? So you know from the top to the surface, you know the distance, and you know you will inverse it, so you know the sea level. Quite simple. So this one to combat is quite complex in algorithm to get precise. It's like GPS as well. So this training course, because you like to measure height with GNSS, it's quite similar to this altimeter. Altimeter is one direction, just to measure height. But with GPS, you measure XYZ. So you extract that. So how to get precise distance from this one? So you measure this one, right? Distance from this one. To get that, you have to compute orbit, the orbit of this, and then atmospheric propagation. You have to make a computation to model it, and then the surface as well, it's dynamic, so you have to do that. I was lucky. I got from NSF research funding in 2013, and I got experience to process raw data of satellite altimeter. We collaborate with Colorado University and from Italy as well. So this is to compute this C-state bias, this one, geophysical, because there are quite lot but this noise here as well, so we have to filter that. So this is fine. Just to let you know that the data obtained from altimeter will be used to compute sea level tide correction worldwide, where no tide gauge available. So that's what in our second session we will be doing that, and to have a simple processing. using Tide model driver, PMD. Okay. Oh, this is the beauty of this one. Satellite altimeter. You see the terrestrial, the distribution of tide gauge is all along the coastline, and we have some buoys, right? But buoys, to be honest, it's very expensive, and to get it continuous observation is very hard. It's a limited numbers of buoy all along the world. So, like in Indonesia, you see this 160 stations. But you see in Borneo, there are no ports here. There are large gaps here. In Papua, only one station in Merauke, but the other, no jetty ports there. So, it's quite dangerous when you sail over there. Because to set up station, like a permanent station or piers there, it's quite expensive. There are in this area in Papua here is a delta region, alluvial. So to get like rock there or to make a fundament, you have to take from other place. It's quite expensive to build permanent buildings. So it's made of, most of the buildings are there are made from wooden. Yeah. From space, this is the orbit. Sorry, it's not so clear, but this is the orbit. Right? The projection of the scan of the terrestrial satellite disturbed some by power system, like a communication line. You will learn about it. There are so many obstacles doing terrestrial observations. Yeah. But if you take it from space, because it's automatic there, yeah, it's quite more homogeneous. Yeah. So,
Parluhutan,
yeah.
I also asked this question to the earlier presenter. The term GNSS type refers to the floating buoy,
Yeah.
right?
Yeah.
But what is your opinion? If it is worth it to have it here in Indonesia? I mean, do we prefer to have more coastal base station plus satellite? Because floating offshore buoy,
Yeah.
there are also vandalism there. People collect it for souvenirs, right?
Yeah.
So what do you think?
So open seas, so that's why altimeter could measure open seas, but they have a limited because it measure from the space 800 kilometers away. So you see, you need to model any effects along the propagation to get precise. Right, open seas. So if you have in the coastal area, coastal lines, you measure with tide gauge, but the behavior of sea waters are distracted by deflection of the coastal, right? So you need to go more to the offshore. How to measure it? Using buoy, okay, that's great, right? So that's why you fill the gap between open seas, coastal, and buoys is very good. Like here in Indonesia, how do you know the characteristic? There is no islands, limited islands here, right? In the middle of this one. So, but the distance is about not than 200 miles, right? So you can, if you have buoys there, several buoys, and then in the future, if you have a navigation buoys, you put sensors there, and if you have more and more cheaper, precise GNSS receivers, it's nice to have that, right? So we need more and more sensors on the seawater. Yeah. So that's the advantage of that. But the challenge is how to control the buoys, how to maintain the buoys. You know, sailing cost to maintain that one. Yeah, how many dollars per day? Yeah, that's all. Okay, let's see the beauty of that. Thank you, Bob. So we fill the gap. Open seas, offshore, and coastline. Yeah. So why we need real time? Oh, this is the challenge. We need real time. You know, we are living in this industrial revolution 4.0. Yeah, right? Everything is in internet. You need real time. Even your control to your wife, to your boyfriend, everything, real time. Yeah? Everything's in real time now. So, when you have real-time observations, you will know more and more knowledge on the behavior of what you are observing. So, real-time provide data streaming. In the past, to have data like long-term data in the past is very difficult. I did a very laborious job when I have a analog tidal recording or paper chart recording from the whole Indonesia, like this. This is from the station.
I think the microphone shall be turned off. Just turn it off.
My sound is quite loud. Okay. Like this in Indonesia, based on paper chart. So we call them, no, there was no mobile phone at the time. Imagine, in 10 years ago, mobile phone, well, minimum, yeah. 20 years ago, no mobile phone. So we went with local line telephone, you know, just when we call them, it's very difficult to get the person in charge. Oh, he's busy, he's doing survey, right? Then, okay, when we got them, okay, how the station is, okay, yeah. Okay, please send the data record, the chart, paper chart, right? Oh, we spend time, we are respecting the time. But when we read that, there's no data on the chart. Yeah. We cannot control the station, whether it's correct or not. You know why? We train the local people, but you know the local people education is not the same from place to place in Indonesia. You go to the eastern part, yeah, the education must be secondary school, high school. No there's no university background at the time. But now it's moving. Yeah. When we get the data, no quality of good record at the time. It's very difficult. So that's why, thanks for the technology to get the data from Indonesia. It provides data streaming, even from the eastern part of Indonesia, because we got this one. This is very cheap. You know how much to subscribe for data streaming in Indonesia with this mobile phone? Can you guess, my friend? $6 only. $6
per month.
per month. It's very cheap, right? So you put the modem there. Yeah. So you can make ease of performance. You can see the performance of your. You can check anytime. I will let you know. You optimization of the sample, and then you can introduce threshold, the interval, yeah, of sampling rate of the. Okay, 1 minute, every 1 hour, daily, yeah. So you can optimize and you can introduce early warning system. If it is not real time, no chance for early warning. Yeah. Then the beauty is it improves our understanding. Yeah. So how to implement real timeness? So this is one. This is the sensors. This is Internet of Things. Everything, how to get online to the internet. Either using radio, either using GSM or GPRS, or satellite, or cable line telephone. Yeah, this is it. Everything. You should go to this Internet of Things, IoT. I was lucky to have that in chance. I learned that, and I asked electrician, electronic engineer, okay, this I design and all this next. I make the program. It's beautiful. Right. Then this is control room. In the past, this is very luxurious, but now this is simple. This is like control room as well, right?
Yes.
Yeah. In the past, if you go to control room, you are like going to NASA room, right? Or something in our space station, right? Yeah. Right. And this is IT. Everything there is. If you have the data streaming there, you ask computer science, okay, can you analyze it? Can you make this performance? Can you distribute this? Yeah. I was jealous because Grab or Gojek online transport. Yeah, I'm from geodesist. I'm from mapping agency. Oh, when I saw that, oh, they got much money out of our work because they are clever. They have an innovation, IoT, IT. This is it. So we'll see later how computer science make our work very luxurious, fancy, nice, applicable, and commercial. Yeah, this is it. Later. So this is users. Everyone get the data, democratization, or yeah, everyone. In the past, to get real data, oh, very classified. But if you share, if you are willing to share, you get the data. If you make it public, you get the data. If you make classified, commercial, you get it. There are many options, either open source, or classified, or commercial, or limited. It depends on you, so long it's connected to the internet. So if our friend from the army, oh, this is about the security, okay, you can deal about it. Make a very tight protection, right? You control it. But you know, everything on the internet is susceptible or prone or yeah, sensitive or yeah, fragile. It's quite fragile to hacker, right? Even NASA, even CIA can be hacked by Russia. Yeah. So it depends on us. So we have to maintain that, to control that. This is the data. Yeah. So everything, it depends on how we maintain it. We have to take care of it. So it's quite, everything's on the internet now is quite, it depends on you how to make it. But now thanks for blockchain, you can have a very good control on your data. But if you are careless, somebody will take your data. Thanks for the data, right? Okay, you observe, you build that, and then somebody will take your data. Thank you, right? Like Facebook. Facebook, you know how dangerous. They will take the data. I mean, thank you for your work, right? That's it. This is. But you need to be smarter and smarter to maintain your data. Don't blame others. Analyze it, make it more, collaborate. If you cannot do that, collaborate. This one. So that's why if you have data, big data, if you don't know to improve it, you need to have somebody help you. Collaborate. Right. So the user can get benefit out of this technology observation. Let's see. So how we measure sea level? There are three types. Float gauge, you know this one? Float gauge, and then you get the record. Because when the sea level up and down, it changes this one, and then it's recorded and can transmit it. How about the pressure gauge? What's the principle of pressure gauge? Why it can measure sea level? This is it, right? Yeah, pressure, density, gravity. So when you measure P1, you get H1. Yeah. So when you get delta right? That's it. This is it. Up and down. The pressure. The difference in pressure. So this is very simple. Yeah. There are many types of how to measure this more precise. You can grab that. How about this? From the top down. It measures distance, right? Right? So, when you measure from top down, how to inverse it to get sea level is another trick, right? You measure this one, right? From this one. In fact, you measure from tight stuff up down. So it's a trick to inverse it. It's very simple actually. Yeah, it's like a simple numerical geometry. Right. So to make it real time, you have to have a reliable power supply. In a remote area, you don't rely on grid, power grid, PLN. Power grid supply in a remote area is not stable. So if you have interrupted power supply, it means your observation finish, shut down. So you have to rely on. Thanks for the technology, solar scale. It's simple, you get this, and then you have the battery. And the sensor it consumes less and less power. So for this battery, you can get 1 month without support from this one. So that's why to feel. But you need backup from this one for battery continuously from time to time. So if you have uninterrupted power supply system, it means you have a continuous observation. If you are from remote, you can interrogate or you can monitor it from remote. The condition of your battery, power supply. This is it. So if in Papua, I can get 5,000 kilometers away. Papua is in the easternmost of Indonesia, right? It's about 3,000 kilometers away from Jakarta. Okay, interrogate. Oh yeah, okay. So it can last, normally this one, 2 years. Change 2 years. But you can get more better battery quality now. Then, yes, the data logger. If you have sensors, that means you should have computer or data logger there to control your system, right? So this is it, microcontroller. Actually, if you are interested in this, you can do it now. You ask your electronic engineer, your friend, do it. I will concentrate on this. It is now Industrial Revolution 4. You have opportunity. You can go to what? To online shop to buy this component, electronic component. Yeah, so observe. Right. So this is one. You control your communication line, GSM or satellite or radio, and then you control the power supply. You control the sensor or the force. Yeah. You control the time, GPS module. Yeah, use GPS time to minimize time drift. You know, time is very important in measurement. If you have a wrong time, it means your observation is wrong. Right. Memory card. Now memory card in the past is only how much? It's quite small. Now 16 gigabyte. It's very cheap. How much? How much? Young lady. How much for 16 gigabyte? Oh, $3. Yeah. When I did my, like you, in 25 years ago, to buy 1 gigabyte, like floppy disk. I started with floppy disk, right? It's about half gigabyte. Not half gigabyte, half megabyte. Half megabyte. Now, you see this one? 16 gigabyte. It's very simple. Yeah, floppy disk. And this big floppy disk like this one, computer. You insert this like this in. Half megabyte. And then 2 megabytes. So
You can have loads of
you know how I'm still young. Yeah. Right. This is it. Now 16. You can imagine 16 gigabyte for continuous observation. Sampling rate. The sampling rate you can record every 1 minute. 1 minute sampling. It's very crowded, right? 1 minute or 30 minutes. It can store the data for 7 years. Here. You can calculate it. How many? 1 gigabyte. One data, one epoch, it's only 0.1 kilobyte. Yeah. Right? So this is SIM card. So this is what we have. Yeah. We designed this. It's not complicated. You can use mini PC. Mini PC. If you design, yeah, you have to design your PCB, printed circuit board. But you can use mini PC. Now, it's getting simple now. So everyone can manufacture their own simple tide gauge. Earth monitoring. So we monitor Earth, other seawater, other land. So in the future, we expect it. As we are from Earth science, we are expecting with the real-time observation, earthquake prediction. We are approaching that. In the past, to get earthquake data, It's quite rare, you know. But now it's, you got more and more. You have accelerometer, you have data from GPS, GNSS, like tsunami. Tsunami later. Tsunami is not quite dangerous anymore. We can predict, we can monitor tsunami. But what we cannot predict is earthquake. If we cannot predict earthquake, we can get. Because earthquake trigger tsunami. So if you can get, okay, to make preparedness. Yeah. Right, communication line. This is quite difficult. But you have a module, this one. Modem. You know how much this one, this modem? You got on board this one. Yeah. It's not more, less than $50. Yeah. So go online. Yeah, go. Ask Uncle Google. Yeah. Yeah. This one, radio. Radio is complicated. You know, 3G, 4G coverage in Indonesia, most of big cities, small cities, you can cover. But if you go to a rural area, you still have blank spot. So you need to go to this radio. Radio is quite laborious. It's difficult. It consumes power, more and more power. It depends on weather as well. Yeah, you are familiar with this. You are from, you are mariners, right? You experience difficulties when you are very different situation of climate or weather, right? It disturbs the radio communications. So the data communications to maintain continuous observation with radio is still quite difficult to maintain in the long term. But for this thanks for the GPRS, right? Okay. And